So hello guys, welcome to my Logic Design 0 to Hero of this course. This is the part 1, also known as the introductory. Okay, so here's the overview. So first question, what will you learn and be able to do? So you will be able to make your own microcontrollers, MC, and CPU, GPU, and even your own whole assembly architecture. And also you can make your own computers with customized features and create new chips. So let's check our brain requirements. I named it mindset so it doesn't feel so rude. The first requirement is proper foundation in algebra. 2. Knowing to turning and switch off and on and off. That's a joke, man! At least know binary. So what the hell is binary? 0 means off, 1 means on. And b is equals to... Okay. So now we will talk about truth table, okay? In a truth table, you can plot input values and output values during a circuit testing, okay? So for example, here is a gate, okay? Gate, and then you create this input is A, this input is B, and the output is O. For example, 0, 0, 0, it depends on the circuit. 1, 1, 1, it depends on the circuit. And this is how you plot the values in and out. So now let's see the logic. So for your easiness or something, you must use Logisim evaluation. And if you cannot install JavaScript, then I have a C version of it, okay? Just contact my Telegram group, official Telegram group, which is here, and then in there it is called the logic, okay? And then you'll get it. Okay, so after you've installed an app, just open the app and then let's start logicking. So where's that thing? So here are the gates, okay? In this video we're gonna learn 1, 2, 3, 4, 5, 6, 7 logic gates, okay? Which are fundamental. So let's start with this, okay? Let's start with this. I will teach you the Logisim evaluation using later, but remember, this is, if you click on this, it is called the construction mode, and this is called the simulation mode, okay? Fuck it, they kill. So we're gonna start with AND gate. Put it right here, and you can see 3 input and 1 output. So let me get these input headers. If you export this to an image, it will kind of look like this. So let me get this thing. So here's a sample circuit, and in the compiled version it will look like this, okay? And the other things are, the output operand is this, the input operand is this. Okay, so back to the thing. And 1 output operand. Okay, let's connect it. we'll name it AND gate. So let's switch to simulation mode to see what's going on. So here is our truth table. So we'll call this input A and this input B. Okay, A, B, and O. So 2 inputs and 1 output. Okay, so what will happen if the inputs are equal to 0 and 0? So the thing is always will equal to 0. 0, 0, 0. What if is A equals 0 and B equals 1? Okay, A equals 0, B equals 1. It's still 0. So bullshit. What if A equals 0, sorry, A equals 1, B equals 0? So 1, 0 is still 0. And what if both of them are 1? It's equal 1. So here's Truthtable and K. Table for AND K. So now let's move on to the next part, which is called an OR gate. Okay, OR gate. So make sure you're in the construction mode. Now 2 inputs, 1 output. Okay. These are plugged in. So now let's create. So this is A and this is B, O, or gate. Okay, now let's switch to simulation mode to simulate what's going on here. Comma B, comma O. So what if the 2 inputs equals 0? 0, 0, 0, 0. What if A equals 0, B equals 1? B equals 1. It is 1. What if A equals 1 and B equals 0? It's still 1. What if both equals 1? It's the same thing. Okay. So you need to memorize the symbols, okay? I'll also put up the symbols in my Telegram group. Okay, to covered. And now we are gonna switch to NOT gate. Okay, so NOT gate. Here it is. NOT gate. So here it is the NOT gate, and it has only one input and only one output. So, comma O. So we'll call the input as A and the output as O, and this is called the NOT gate. Okay, so now let's simulate AO. What if A equals 0? So A equals 0, O equals 1. Now what if A equals 1, O equals 0? So simple, right? Not gate. So now we're gonna now say exclusive OR. Exclusive OR. Exclusive OR. Let me widen it. So 2 inputs as the same as shift. Again, let me tell you that if you do not have Java installed in your Windows operating system, or you can't install, then go to my GitHub repository and then download this, okay? I've coded the whole source code in C, okay? So it will be pretty, yeah. Okay. So 0, 0, 0. But note, this thing always belongs to the Logisim creators, but since it's open source, they won't mind. Now let's start with exclusive OR. So I'm tired of copying these, okay? So this is A and this is B and this is O, the output. A, B, O. So what if A, B and B equals 0? The output is also equals 0. And what if A equals 0, B equals 1? The output be 1. What if A equals 0, A equals 1, B equals 0? Equals 1, B equals 0, it's still 1. Now, here's the main thing. What if both equals 1? It's 0. I thought. And this is the exclusive OR gate or XOR. Okay, what do we have here next? So we have a full adder, okay? So what are the ingredients? 2 things and 1 it. So input shall be 2 bytes and output also shall be 2 bytes. It will be a half adder of 2 bits, also called as adder. Okay, how to code this? No coding. We could just some decent drag and drop, but not WordPress. So this is B, this input pin is B, and this is called A. Okay, AB, and out A, and out Okay. So now here's so we're gonna make our first computer. Okay, first self-computer, mini computer of 2 bytes. So you can call it like a micro mini CPU, which is basically a baby only knows to do 1 plus 1 and nothing else. But it says 1 plus 1 equals 10, which is in binary. So the baby must be pro. So we need an XOR gate, exclusive OR. Exclusive OR, B equals A. Now let's connect these. If you can literally connect these. Okay. Oh. Okay. I'm at the correct destination. Okay. If you can make a better, you just try to make it a straight line. Okay. Try to make it, but I won't mind because you're a baby steps learner. Shouldn't have said that, but for your own safety. Make this wide, because I cannot see the holes. So the first pin of this thing, the left pin, if you reverse it, goes to the up. Okay? And the down pin goes to B. Okay, remember that. And then let's add out A, and let's set out B. So our shit is looking good to go. Yes. Okay. So we've created an half adder. Okay, so let's go to full simulation mode and create a table for test table for half adder. A, comma B, comma out A plus out B equals sum. Out A plus out B equals sum. Okay. A equals 0, B equals 0, out A is equals 0, sum equals 0. Okay. So you're not supposed to do this, okay? You just rotate it a little bit. Mean it's horizontal or vertical, I don't know. Let's say it is in Y plane, because I'm putting English. You must bring this circuit to an X, okay? But since you're a beginner, this is the best. So if B equals 1, so let's try to do a sum, okay? Which is testing sum equals 1 plus 1. 1 plus 1. So let me pull out my binary chart, and luckily I have no camera to show you guys. So once binary is 1, and okay, 1 goes into A, 1 goes into B, and we get 1 and 0, which can be called as binary 1 plus binary 1 equals binary 10 equals 2. So how is it 10? The out A goes into the first digit and the out B goes into the ones, and the B goes to tens. So it cannot do pretty much. But hey, you've created your own first computer. So this is just the lesson, and your 8th homework is to get informations of NAND, NOR, and XNOR. So let me write it. Oh fuck. So let me write that HW number 1. Get the truth table of the